Projectiles, inclined plane, type 1, basic, and also downhill. So this is quite an interesting question in 1997 because we have been given a particle projected from a point P with an initial speed of 50 meters per second down the plane, which is inclined at an angle of 30 degrees to the horizontal. And the direction of the projection is at right angles to the inclined plane. The first thing we have to do here that makes it interesting is find the perpendicular height of the particle above the plane after t seconds, and hence or otherwise show that the vertical height h of the particle above the plane after t seconds is 10 root 3t minus 4.9 t squared. So let's mark in on our diagram exactly what it is we're going to have to do here. So let's zoom in here on this diagram. So the first thing we have to do is find the perpendicular height with respect to the plane. So if I mark that in, essentially what I'm doing is I'm looking for this distance here, which is basically sy, so the height above the plane. Whereas we're looking for h, which is the vertical height with respect to the plane. So essentially I've just drawn a right angle triangle, and if we notice with this right angle triangle, if this angle here is 30 degrees and this is 90, then these two angles here must be vertically opposite. And if this is also 90, well then that means that this angle here within this triangle is 30 degrees. Okay, so let's make out our table. So we're going to have U, A, V, S, and T in the X and in the Y direction. Okay, so we know that our initial velocity is always given by U cos alpha in the I direction and U sine alpha in the J direction. And when we're going down the hill, we also have to resolve our gravity. So if we have G going down, then we know when we resolve it, using a different colour pen here, that we're going to have G in the Y direction is going to be negative because it's the opposite direction to its initial velocity, and G in the X direction is going to be positive because it's the same direction as U in the X direction. So essentially we have G sine 30 in the X direction and G cos 30 in the Y direction, but it is negative. So filling in our table, because it was projected at right angles, that means it only has a velocity in the Y direction, so it has no velocity in the X direction, because we were told up here in the first paragraph the direction of the projection is at right angles to the inclined plane. And that's clearly drawn in the diagram here, so we only have initial velocity in the Y direction. So therefore that's 15. A in the X direction, we saw there is G sine 30. So sine 30 is a half, so that's going to be G over 2. And in the Y direction, it's minus G cos 30, and cos 30 is root 3 over 2. So that's minus root 3 G over 2 for our acceleration in the Y direction. Given that V is equal to U plus AT, that means that V in the X direction is going to be 0 plus G over 2t, and V in the Y direction then is going to be 15 minus root 3 over 2 gt. We know that S equals ut plus a half at squared, so therefore S in the X direction is going to be a half of G over 2 times t, so that's going to be G over 4 t squared, and then in the Y direction it's going to be 15t, and then minus a half of root 3 over 2 is going to become root 3 over 4 gt squared. Okay, so using this table then to find our perpendicular height, so looking at h here, we need to basically know what is sy. So sy, we have 15t minus root 3 over gt squared. This will be our perpendicular height above the plane. So we know that sy is 15t minus root 3 over 4 g times t squared. But if I go back to that diagram, we can also work out sy using a bit of trigonometry here. So let me take that triangle out here. We have that perpendicular height sy. This was h. This was 30. So therefore, by Pythagoras, that's the opposite, the adjacent, and the hypotenuse. And therefore, if I'm looking for sy, I'm looking for the adjacent side. So basically, I can say always that the adjacent is always going to be h cos theta. So in other words, I can say that sy is my adjacent, must be equal to the hypotenuse, which is h, times cos theta. Well, theta is 30 degrees. So in other words, I can say sy must be equal to root 3h over 2. So now I have two equations for sy, that perpendicular height above the inclined plane. So all I need to do now is equate 1 and 2. So by equating 1 and 2, I have root 3 over 2h is equal to 15t minus root 3 over 4 gt squared. If I multiply everything across by 2 there, actually I multiply everything across by 4, I should say, just to get rid of those fractions, then I get 2 root 3h is equal to 60t minus root 3 gt squared. And then if I divide across by 2 root 3, I end up with 10 root 3t minus 4.9t squared. So, interesting question that, but very nice. And of course, setting up this h cos 30 was basically hit or miss in terms of its marks. So it was either right or it was wrong, which can often be a bit mean sometimes with hit and miss marks. And then the second part there was showing that it was equal to it was going to be 5 marks. Okay, so the next thing it wants us to do then, if we go back to the question, is to find the greatest vertical height that it attains above the plane. In other words, the maximum value of h. And we have to do that correct at 2 decimal places. So we have just found h. So we've just found h. It's 10 root 3t minus 4.9t squared. So even if you didn't get that first part out, you've lost your 10 marks. You might have gotten some attempt marks there for the second part. But we have been given the equation that we need to work with. So to find the maximum vertical height, well, essentially we're going to be differentiating. So in other words, we're going to be getting dh dt, and we're going to have to let it equal to 0. Okay, so if h is equal to 10 root 3t minus 4.9t squared, then when I differentiate with respect to t, that gives me 10 root 3 minus 9.8t. And then by letting that equal to 0, well, that gives me 10 root 3 minus 9.8t equals 0. And therefore t must be equal to 10 root 3 divided by 9.8. And that gives me 50 root 3 over 49 seconds. Okay, so therefore my maximum height, well, all I need to do is sub that back in to the equation. And obviously if I was to do a second derivative test there, we'd end up with minus 9.8, which is negative, and therefore the second derivative is less than 0, which is obviously a max. So we can only get a maximum here, okay? We don't have to do our second derivative test. So our maximum height is going to be 10 root 3 times the time minus 4.9 times t squared. And I'm keeping it in terms of thirds until the very end because we need to find the answer correct to 2 decimal places. So it's easier to simplify at the end. Okay, and that obviously is t squared there at the end there. And then that gives us 15.3061. And of course, correct to 2 decimal places gives us a maximum height then of 15.31 meters. We had 5 marks for our differentiation, 5 for getting our time, and 5 for getting our maximum height. So a nice question, different type of question, and just one to be aware of.